Yeah, so let's get started. Yeah, so let's get started. Mm, Let me just check if yeah my screen is shared, right? Mm, Can anybody confirm whether you are able to see my screen or not? In chat box also you can type. Visible, na? Okay, because actually I got one call just now, and myself is not able to see the screen. So let me just see. Yeah, because I'm already sharing. It says I'm presenting. One second. Why am I not able to see? Mm, One second. I'll start, but let me rejoin because yeah, I think that's fine. Yeah. Mm, mm. Okay, I think it's all good now. So let's get started. Uh, in this week third, there was discussion on various types of payment series. So we'll talk about those only. And there are a lot of formula, but no need to worry. I mean, if you should remember something like if you have some memory map or anything, it will be better for you to remember all those things. And you know uh, I'll just briefly tell you what all you should remember, because there were a lot of formula in week 3, and you don't need to remember everything, because then it will be difficult to mug up all those things. So yeah, so uh, let's go one by one, so that we'll have some uh, clarity as to what should be done and what should be and how should you go about this. Okay, Lalit is typing something, so let me just wait for it. uh, my voice is on, right? Yeah. So the first thing was this single payment compound, or single payment uh, kind of series. Financial calculator is allowed in the exam or not? What do you mean by financial calculator? That I don't know. I mean, as far as exams are concerned, there are two types. One is regular calculator and one is scientific. So, financial calculator, what do you mean by it? I don't know. As far as I mean, I'm not sure, but you should clarify this with this NPTEL team, because I have not applied for any exam on NPTEL. I think basic calculator will be there, but I'm not sure whether scientific calculator will be available. So I'm not in the I'm not the right person to answer this question. You should write a mail or something to NPTEL, getting the clarification from them. Okay. So then we have first thing is about the single payment. Okay. So it's not actually series. It's basically uh, you know uh, single payment. Uh, I mean, there are no multiple these things. Uh, you know, like annuity or dispersal or something like that. So it's just that you invest some amount today, and after n number of years, when it is compounded annually, how much do you get? So that is one way, and that is called as. So there are two things in this. So first is called as a compound amount factor. Okay. So as the name suggests, it's like if you uh, compound your present principal P, how much do you get after n number of years, provided your rate of interest is I per annum. Okay, so it's a not a simple interest thing, it's a compound interest kind of concept. Here you have this f equal to p 1 plus I whole power n. Okay, so f is your future value, p is your current principal or current value, I is rate of interest, and is number of years. Okay, and this multiplier is called as compound amount factor. Okay, so uh, this is this multiplier, and sometimes it is, since we use different tables, so sometimes this is written as f by p I n. Okay, so why do we write it like this? Because there are some interest tables, or uh, you know uh, like different tables, so you will have various values of f by p for different I interest rate for various number of years. Okay, so like that. Okay. So this is going forward. So basically, if you have some amount today, how much do you get after n number of years? But sometimes they ask the reverse case. Okay, so basically they will ask that after n number of years, you should have this much sum. So how much you should invest today? Okay, So it's just the ulta of this thing, and it is called as a present worth factor. So single payment present worth factor. Okay. So if you pay attention to the names, then you'll realize what they're asking. So the first way they're asking about uh, compounded amounts, that's like they're asking future value, and then you have present worth factor, so that is like present value based on certain future value. Okay, so here it is just the ulta. So basically you write this p as f into 1 plus r power minus n, or r is I here, so like that, and this is the factor. Okay, so this 1 plus I whole power minus n is the factor, and sometimes it is written as f into uh, p by f comma I comma n. Okay, so you need to refer to some interest or this factor calculation tables. So where there will be n as 1, 2, 3, 4, 5 like that, and then for particular I you will have certain p by f value for particular n. Okay, so this is regarding the first two formula, which are easy to remember, because it's basically you just put some money in, let's say, bank FD, and it is getting compounded annually, and at the end of your maturity you just take out that money. So problems like that. So typically, you'll see some problems where you have, let's say, somebody is doing this FD for his kid. So after 20 years, how much amount he will receive, or if he wants certain amount after 20 years for the education of his kid, how much should he or she invest today, like that. So these two formulas easy to remember. You should be able to do this. Then there are three formulas for equal payment series. Okay. Not three, actually four. Okay. So this is nothing but equal payment series. So for this thing, single payment, it was only two formula, but for equal payment series, there are four. Okay. So we'll call this as EPS, let's say. Short form we'll use because this gets repeated in all four, so it's easier to do that. So first is EPS, compound amount factor. So that means equal payment series compound amount factor. So again, this compound amount factor, it's basically, this keyword, it is nothing but used for uh, related to the future value. You will have certain this thing today. Since this is equal payment scheme, you will not have certain lump sum amount P. You will have some annuities or equal installments of certain value A. And if you do it for n numbers of years and each of them gets compounded by some common interest rate I, how much do you end up with at the end of the year or the maturity? Okay. So this is again forward looking. So I'll just mention the keyword so that you will understand what are the significance of these formulas and where do we use them. Okay, so forward looking means from current status of these things, what would you get at the end of certain maturity. Okay, so this derivation was done in the calculation class. Basically, you have some geometric series with A as the annuity amount, which is the equal payment amount, and then you basically sum it up, some finite geometric series formula you use, and you write this as f equal to A, and in the bracket 1 plus I whole power n minus 1 I. Okay, and this factor, this bracket is the factor basically that you get from different tables. If you don't have table, you have to do the calculation. Okay, because I and n are usually given in the problem. Otherwise, if n is unknown, then other f and a will be given, something like that. So there are four variables in this equation. Three will be given, one will be unknown, and then you have to solve this. Okay. So sometimes when you have the access to the various tables, so this will be your um, f by a table, f by a, okay, comma I and n. Okay, so this is the notation basically. So for particular n and I, you need to find this f by a factor from the table. Okay, and multiply that with a to get f. So this is first one. Then the second formula is this equal payment series EPS, sinking fund factor. So as the name suggests, it has a negative connotation to it. So that should give you the hint that it is like a backward looking. So basically, at the end of certain year, certain number of years, you need certain amount. So what SIPs, this is a new hot topic nowadays. This SIPs that you do for mutual funds, etc. After COVID, it has blown up like anything. So yeah, so at the end of the your professional life, if you want certain number of uh, lakhs or crores of money, how much SIP should you do from today? And SIP is like monthly, so that at the end of certain number of years, that you should have enough retirement funds. And it's similar to your NPS also, like all those NPS and similar schemes. So basically, monthly you put something, and in NPS etc. you have like more or less fixed interest rate, but in stock markets or financial markets, uh, I mean equity markets, basically you don't have that interest rate as a certain constant value all the time. Many times it is high, many times it is low, but on an average, it will give you GDP plus inflation on a index level. Okay, plus some growth multiple or growth premium that you can get if you are a high growing economy. All those things are there, but that is on a larger scale. If you are talking about 10, 20 years like that, on an annual basis, you can't predict anything there. Okay, nonetheless, we'll come back to our discussion. So since it is backward looking, so this is is basically you need to find A, how much monthly installments should you uh, pay, so that you will end up with a decent amount of this thing, or required amount of savings at the end of certain period. Okay, so it's just a reverse of the first case, and here this is the factor that we mentioned, and sometimes it is written as f into a by f comma I comma n. Okay, so this I, like this three bracket comma I comma n, this three argument notation is the standard way conventionally followed in most of the cases, so that's why we are also following it. Okay, so you'll get this a by f fraction or number from the tables if you have access to them. Otherwise, you have to do the calculation from the this I by I plus 1 and minus 1 formula. Okay, so these two cases are the similar ones. And then you have uh, ulta case. So basically, you know, yeah, so basically I should say this is forward looking from A, and this is backward looking from A. So basically what I'm trying to say is you are looking at monthly installments or different annuity amounts. You don't have lump sum, okay, but you can have lump sum also, right? So I mean, at the present day, you will have some lump sum amount, you will do some FD, and then you expect some monthly outlays. Okay, so that is the uh, next thing. So before that, maybe the correct way should not be A. See, forward looking to F. Okay, and this is backward looking from F. Okay, so you have certain future value in mind, and then you are doing all the calculations. One thing is you are targeting certain future value, and then how much SIP you are doing. Another one is you know the uh, future value that you want and how much SIP you need to do going backward. Okay, so like that. So then another thing is let's not go into the future. Let's stay at the present value, that you do some FD or something. Then how much equal monthly installments would you get? Okay, so in that case, it is called as EPS, equal payment series, capital recovery factor. Okay, capital recovery factor. So here you are basically looking forward, because your objective here is to um, 1 second. Or maybe instead of doing forward looking, I should simplify this because it may confuse others. So it's like extension of problem number 2. Okay. Okay. So we'll solve some problems, then it will be clear. But more or less, it's like extension of case 2. Okay. So how is it extension of case 2? Is basically from case 2, this A is nothing but some f into a by f comma I comma n. Okay. By 1 plus I power n minus 1. Okay. So now you don't put this in terms of f, you replace it is in terms of p. P is nothing but present value or current principal that you have. Okay. So that comes from this thing. Very good. Yeah, this one. So if you want to understand in the context of these two, let's call them A and B, the first two cases. So it is nothing but extension of case 2 and this thing, case A. Okay, so basically you mix two previous cases to get this one. So here you used case 2 for this equation of A, and then you replace f with f equal to p 1 plus I whole power n from A. Okay. A means that case A, okay, not the annuity amount. Okay. So therefore what you have, A equal to p into 1 plus I power n in bracket I divided by 1 plus I power minus plus n minus 1. Okay. So now this is your factor. Okay. So this you can write it again as this thing a by p comma I comma n. Okay. So then you get this a by p factors from your tables if you have access to tables. Otherwise you have to use this formula in terms of I and n to get the answers. Yeah, Lalit, I'll share these slides. Actually, I share my notes every week with the NPTEL team. I'm not sure how they share these things with you, but you see, usually from where you download the videos, no, there is one OneDrive link in your course content. Once you open that OneDrive, there are YouTube video links, and then there is one folder link also where I share these notes every week. So after the class I'll put it there and you can download it from there whenever you want. Okay. And then the last case of this EPS series, which is called as EPS present worth factor. Okay, so here basically you basically start from this thing, like if let's say okay, now you want everything in terms of P, not in terms of A. So it's like reverse of case 3. Okay. So what do I mean by reverse of case 3? It is nothing but P equal to A into the reverse of all this whole bracket. So basically it will be 1 plus I whole power n into I divided by 1 plus I whole power n minus 1 inverse of this. Okay. And then it is also called as A into A into what should it be? 1 second. Let me just check. Yeah, it should be P by A. P by A comma I comma n. Okay, so depending on what data you have, basically you have to use the tables or use the mathematical formula for this factor, and this is that factor that is mentioned here. Okay, so these are 4 cases in your EPS series. Okay, so you should remember that way so that you don't get confusion. Okay, so two cases in the first part, and this thing, 4 cases in the second part, and now there is a third case which is called as, see, this is equal payment series, right? So now you have something called as gradient series. Okay, so there is something called as gradient payment series. Okay, so as the name suggests, it's gradient, right? Gradient means rate of change of particular quantity with respect to underlying independent variable. So here, gradient payment series essentially signifies that you don't have equal amount in installments. You have gradually increasing or decreasing installments, okay, depending on the problem. So here also you'll have 2 cases. So let's denote them by Roman letters. One, which is called as uniform gradient. Okay, uniform. Let's say I'll use GPS for this gradient payment series short form. So uniform gradient payment series factor. This is the first case that you should know. And as the name suggests, the keyword is uniform. So that means it will uniformly increase the amount of annuities or installments or SIPs or whatever you want to call it. They will uniformly increase. Okay, so starting from first month, like that. Okay, so in that case, this G is like, see, right now only A, P, F, these 3 variables are coming into picture. So for this uniform GPS thing, one capital G also comes into picture, because these things, these payment amounts that you need to do, they are not constant now. So they are calculated in terms of some variable G, which is nothing but 1 by I minus n power 1 plus I whole power n minus 1. Okay, so how this factor comes, that derivation was done in the class, so we can't do it here because otherwise it will take a lot of time and we'll not be able to solve anything. So again, this is the actual formula, but if you have access to some factor table, so this is written as a by g comma for particular I and n. Okay, and this j is nothing but this gradient, okay, or uh, the amount by which every installment is increasing, and in this case it will be a constant. So this will be a constant gradient. Okay, it can be positive or negative, doesn't matter. There is no restriction on its sign, but it has to be constant. So basically, it's like an equation of line. So the slope is constant there, right? So like that you can remember, or you can draw the analogy from there. Okay, so this is one series, and then there is the counterpart of it. It's nothing but the second is nothing but called as geometric gradient series. Okay, geometric gradient payment series factor or something like that. Okay, so here this this is that factor that comes into picture because of uniformity of this annual payment or equal interval payments. Okay, so here basically your these things, these amounts that you pay, they increase in a geometric series fashion. That's why it is called as geometric GPS. Okay, so again, there is a derivation which was done in the class. If you are interested, you can go through that. But here the derivation is slightly tricky because it has 3 cases here. So there are 3 sub-cases here. So we'll just go through them. You know. So here the uh, the the annuities that you pay, let's say for after t number of time intervals, will be nothing but function of the first annuity that you paid plus some constant g value, and then t minus 1, and t goes from 1 to n. Okay, so if you pay attention, this is like a geometric series formula for tth term. Okay, so this is nothing but tth term of a geometric progression with a1 as its first term and 1 plus g as the common ratio. Okay, and that is the basis of your derivation there. So once you do the derivation, basically you get this factor, which is nothing but the P that you need to invest today as a function of the first this thing, first installment divided by 1 plus g. In bracket you have 1 plus g dash whole power n minus 1 divided by 1 plus g dash whole power n into g dash. Okay, so this g dash is nothing but where g dash is a derived variable, which is a function of g and I, is given by 1 plus g and 1 plus I. Okay, so based on this, this is the criteria for further subdivisions. So there are, you'll have three cases here. Okay, so maybe I'll just note them down here itself so that it will be easier to study if you are doing it later. Okay, so this will be like second sub case A, that is when this factor g dash is greater than 0. So what it means is if you can put the value of g dash, that means 1 plus g divided by 1 plus I is greater than 0, right? So if you do some simple methods, simple simplifications, that means g is greater than I. So what it means is the interest rate that you are getting, I, is smaller than the growth rate of your installments. Okay, so that is first case. In that case, then you need to put this value of g dash in your formula, and then you'll see uh, certain implications of that. Second case could be, let's say second B case. If this g dash is less than 0, so you have to do the same derivation, you'll get g less than I. So this is the second case that is possible. And third case is, if g dash is 0, that means g equal to I. Okay, so in that case, if you put g dash 0 in this P formula, basically you'll get 0 by 0. So then you have to do some L'Hospital rule, limit you have to calculate. Okay, but I think in the end you just get n equal to n. Okay, so this in this case you have to use L'Hospital's rule. I hope you remember, what is L'Hospital's rule, because this is to solve this 0 by 0 limit. Okay, because when you put g dash equal to 0 in this factor, that is 0 by 0, right? So you have to differentiate once and then put g dash equal to 0. So we are not doing that part, but if you do that, you should get this P equal to A1 by 1 plus G into N. So that should be your answer. Okay, so this could also be one of your exam questions, similar to like this. Okay, so, and yeah, I mean, this is the actual one, and otherwise you can write this also as equal to this A1 by 1 plus G, and if they have these tables, then they will give you this P by A, or this thing, into G dash into N. Okay, so for given G dash and N, you need to find P by A from the table, and then if you put this in the formula, you will get it as A1 by 1 plus G. Okay, so these are some cases that are there in the geometric GPS. So just to do a brief revision, there are two cases in the single payment series or single payment type of problems. Then there are 4 cases in your equal payment series, and then there are 2 cases in your gradient payment series. One is uniform, another is geometric, and in geometric then there are 3 sub cases. Okay, so that is like more or less the content wise, formula wise it is there. Then there were some interchanging formula, etc. But if you remember, see for that, uh, you know, uh, the variable, I mean the various interchanging formula. So what I mean is, you know, various correlations for EPS, equal payment series factors. Okay, so you should go back and check these formulas. Uh, See, you can't remember all of them. You know, difficult to remember all of them. Okay, so what you should do instead is, you know, instead remember, there are four formulas in EPS series, right? This 1, 2, 3, 4. Remember these four. Okay, remember four formula from EPS uh, cases and solve the respective question. Okay, so whatever is asked in the exam, because they may ask you to identify the correct relationship between these factors, etc., like that. So you need to apply your uh, uh, you know your brain there, and then you can find the answer. But remembering all those things before the exam, I don't think it's, I mean, I can't do it, so I'm not expecting from you also. So if somebody from you can do that, then it's very good. But I'm talking from a common perspective, like broader perspective. It's not easy to remember all those correlations. Okay, that's why you don't see any problems in your assignments also. But that doesn't mean that there will be no problems in your this thing, final exam. Okay, so there could be some tricky questions from this, but then you should tackle it like this. You need to remember this four formula from EPS, then you should be able to do it. Okay, then after that, there was some discussion on annuity due, etc., and deferred payment, etc. So we'll take some problems on that, because if I give you another formulas, it will be easier, difficult to remember those. But you should remember that's something called as annuity due. So that means you do the payment of your installment at the start of each term. See, normally you do at the end of each term, right? But for example, like insurance or something, you need to pay the premium upfront. Okay, so in that case, the formula for your future value in terms of your A gets slightly modified. It has this one multiplying factor comes into the picture. Okay, so this was discussed in the class. And then there are certain these things, default annuity, all those kind of things. So we'll take those problems, and we'll try to solve them. Okay. So I hope this simplification will help you to prepare these things later. So now let's take some problems. Okay. If you have any questions, you can ask in the chat box. Otherwise, it is also fine. So let's take some problems. So let's start with a simple one. Okay, this first case, single payment case. So 1 second. PF, right? Mm, Actually, I have all the formulas from this thing, questions from uh, uh, this thing. But 1 second, let me just find. So let's see this one. So this is like the first case application. So you know, yeah, I think you'll have certain these this type of uh, problems in your assignments also. So hopefully this will help you for that. Okay. So let's take one problem where let's say Ram wants to uh, have 4 lakh rupees after 20 years for his son's education, let's say. Okay. uh, the single payment he should do today to get the desired amount is, let's say it's a fill in the blank, at 8% interest rate compounded annually from the bank. Okay, so bank, so basically he's doing FD of certain amount at 8% interest rate compounded annually, and after 20 years he wants that sum to go to 4 lakhs. Okay, so this is your application of case B in the first section, the single payment section. So here you have F value, future value as 4 lakhs. So let's say 4 into 10 to the power 5. You have interest rate which is 8%. So you can write it as 0.08. N is 20 because you want it after 20 years. And what they're asking is what is the present value or current principal that you should invest. Okay. So, we have this formula P equal to F 1 plus I power minus N, right? So, in this case, or otherwise, this is nothing but F into uh, P by F, comma I, comma N. Okay. So let's use this one because there is it's easier to do this way. So your future value is 4 lakhs. This will be 1.08 whole raised to power minus 20. Okay. Right. So what is 1.8 raised to power minus 20? Let me just do the calculation. 1.8 08, sorry, 1.08 raised to minus 20. It is nothing but 0.2145. Okay, so this is nothing but 0.2145, let's say, and then you need to multiply it by 4 lakhs. Okay, into 4 lakhs. 4 into okay, so it comes out to be 85,819.3. Okay, so you need to put 85,820 rupees in the bank account and do the FD so that he receives as a single payment of this thing, 4 lakh rupees towards the end of 20 years. Okay. And if you have this, because this class notes were shared, so their tables were given, right? So unfortunately there was the table was not there for 8%, but you can Google it. Let me just see. There is one this thing. Let's say you Google interest factor table PDF. You get one PDF from Iowa State University. It is in US. So they have given a detailed PDF with different interest rates. So there you have 8% interest rate also. So you can just Google interest factor table, Iowa State University. Okay, so it's not that uh, large PDF. Also, you can download it because the notes that were shared in the class, they have very limited amount of data, and so anyway, so what I wanted to tell you is this one. This if I have the table, then how should I go about it? So for n equal to 20, interest rate equal to you know 0.08 or 8%. In that case, this P by F factor from the table that I have in front of me, you can also download it, is directly uh, uh, this factor is coming out to be 0.2145. Okay, so this is exactly what we got from our this thing, and then answer should be same only, right? Because this is same thing only. But the thing is, if you have these tables, it will be very easy or time saving, right? And it will reduce the chances of making mistakes, because these are very important calculations. If you miss any plus minus sign, the whole thing is wrong. Okay, so I would encourage you to download that factor table from Iowa State University. You can have others also, but I just googled it before the class and I found this as the useful one. Okay, so like that. Okay, so if you have these factors, it is very easy. Okay, so we can take the reverse case also. Okay, and that would be nothing but you know that in that case we basically start with some value today, uh, and how much do you get at the end of certain number of years if you have 8% or 9% or 7% interest. So in that case, I'll not mention the whole statement of the problem, but I hope you get the idea that we are just going in the reverse direction. So in that case, what will happen? Let's say you will have this P of, let's say, 1 lakh rupees, and let's say you have time horizon of 10 years, and the interest rate that you get from the bank is 7% or 0.07. And then you need to find the F for single payment case. Okay, so this is your case number A. If you scroll some pages up, that is case number A, the first case that we discussed today. So basically, this is nothing but F equal to P into 1 plus I whole power n, or P into F by P I comma n. Okay. So here basically this will be 10 to the power 5 into 1.07 raised to power 10. Okay. So I'm not doing that calculation because I have the table in front of me. So this will be nothing but 10 to the power 5 into this 1.07 power 10 should come out to be equal to, we are doing F by P, right, for 7%. So F by P for 7% at after 10 years is 1.967. 1.967. Okay. Then it's just 196700. So basically, you'll, instead of 1 lakh, you'll have 1,96,700. Okay. So this will be your answer in that case. Okay. Okay. So let me just check if I. Yeah, 1.971 or something, but it's okay. Okay. So these are two cases from your first type, which is nothing but single payment. So let's now look at something else. Okay. So now let's do something EPS related problems. Okay, equal payment series concept. So in that case, let's see what problems do I have with me. Okay. Yeah. So you know, let's say a person is planning to have, let's say, 2 CR, 2 crore uh, rupees, and after uh, his retirement, okay, which will be, after, uh, let's say 30 years. Okay, so like that. Okay, so his target is at the end of 2 crore, at the end of 30 years of his professional career, he should have the savings of 2 crores so that he can retire peacefully. Okay. If the annual interest rate of, let's say, 7% is assumed to be possible on his uh, you know savings account. Okay, 1 second, this is like, okay, okay. On his savings account, then how much uh, how much annual FD amount he should start with. Okay, so basically I'm asking, see, in this question, this is the language of the question, but if you uh, you know replace everything with the terms that we know, what you want is f value of 2 crores. So 2 crores will be 2 into 10 to the power 7, let's say, and the time period that you are looking for is 30 years and equal to 30, and the rate that you have is 0.07. Okay, and I'm asking you to find the a value, so that this is your annual investment, equal investment. Okay, so equal FD amount he needs to do. So how much FD should he do from now on, so that he'll get 2 crores at the end of 30 years by doing FDs. Okay, so this is your application of EPS series problems or formulae. So here you should look at the problems or the formulas. So here you are interested in A and F. So basically you can use this formula, right? So it is nothing but I by I plus 1 power n minus 1. So basically you need to find A for a given F, and the formula will be, the factor will be 1 plus I power n minus 1. Okay, or it will be F into A by F comma I comma n. Okay, so everything is in front of you. This will be 2 to the power 7. I is nothing but 0.07. This is 1.07 power 30 minus 1. Okay, so let me do the calculation. It is 0.07 divided by 1.07 raised to 30 minus 1. Okay, so it comes out to be 2 into 10 to the power 7 into 0.001512. Okay, I am just writing because it's a very small number, because you have to multiply this by 2 crores, right? So 2 into 10 to the power 7. Okay. 2 into 10 to the power 7. So you should get the answer as 30,246 rupees and let's say 9, or you can round it off to 247. Okay, so you need to do annual investment of at least this amount, so that if you get the 7% rate on your FDs, then you should be able to have 2 crores. Right. See, if you are not convinced with your calculations, see, if you invest 30,000 per year, in 10 years you are investing 3 lakhs, right? So in 30 years you are investing 9 lakhs. So the rest of the amount that you get is basically interest, no? And that is the power of compounding, right? So basically, one more question could be asked is, in the same question, what is the total amount of interest that that is accrued during this time? Okay, so basically, total sum invested would be this 30,247 into 30, right? Because you are doing this for 30 years on an annual basis, right? So 30,247 into 30. Okay, so that is around 9 lakhs, if I'm not wrong. 907410. Okay, and how much interest you got is nothing but total interest will be nothing but 2 CR minus this amount, right? So minus 2 into 10 to the power 7, right? So now you see, it's like almost 1,90,000 or 1,10,000. No, 9 lakhs is, let's say, approximately 10 lakhs. So you will get 1.9 crores of interest. Okay, that is because your initial investments get compounded annually, right? So just for the sake of this thing, I'll give you the final number, 2590. Okay, so it is like approximately 1.91 crores. So you invested only approximately 10 lakhs over the period of 30 years, but you compounded it annually. So that's why at the end of 30 years, what you got is interest of 1.91 crores. Okay, so you should understand the power of compounding here. And that was the point behind asking this question. That with the, see, if you see this 30,000, that means monthly you need to invest, let's say, around 2.5 thousand, right? So but if you have to, like, you need to do it on a consistent basis, and that's what that's why this, everybody, everywhere you'll hear these slogans of these things: long-term investment, long-term planning, blah blah blah. It's just that you have to be, see, the thing is, what is in your hand? One thing is the amount that you can invest every month or every year, and the interest rate. So you don't realize this, but this factor, it is very important. You can repeat the same calculations using let's say 6% of interest rate, then you'll see the difference will be huge. You, to get the 2 crore after 30 years, you need to invest more. Okay, so I'll just tell you Since I have the tables with me, let me just check. So this was with 7%, right? So this was A by F, okay, after 30 years. Okay. Yeah, so here it says the sinking fund factor. One second. It says 0.010, but I got something else. One second. 7%, 30 years, right? A by F, correct? No, because you know F, you want to find A, so it should be A by F. Here it is given A by F of 0.0106. Okay, let me just check now if I had done some calculation mistake. If I had done, then it's very bad. Okay, 0.07, then 1.07 raised to power 30 minus 1. Yeah, actually there is 10 is less here. Yeah, so then it makes more sense, because I was also wondering this interest is too high. Otherwise everybody will do this only, no? So it is nothing but sorry, it is 0.010, not 00. Yeah, I did a typo there. So let's say 06. Yeah, see, that's what I am telling. If you don't have these tables, no, sometimes you'll make very big mistakes. Anyway, um, so that comes out to be 2,12,000. Yeah, now it is fine. 2,12,000 INR. Yeah, so now it makes more sense, these numbers, into 30. Yeah, so 2,12,000 into 30 is nothing but 63 lakhs. Yeah, 63 lakhs 60,000. Okay, and then you need to subtract 2 crores from this. So it's like yeah, this 63 lakhs 60,000. If you subtract this from your 1 crores, you'll get around 1.364 crores. Okay, so even though it's not a small amount, you invested around 64 lakhs over the period of 30 years, and because of compounding, you got extra 1.364 crores as your interest. Okay, so yeah, now it makes more sense, because I was worried because if you get only by investing 10 lakhs, you get 1.9 crores of interest, then it will be very good. No, everybody will do that. Okay, anyway, that was a calculation mistake, so now it should be fine. Okay, so this is like application of EPS when you have equal payment series and some final amount of F value in mind, and then you do the back calculation to get the annual SIP, or even you can do monthly then. So like you need to do annually 2 lakhs, right? So that is like uh, you know uh, 20,000, let's say, less than 20,000, but approximately, or motamoti 20,000 per month. Okay, so that is nothing but, let's say, 212 divided by 12. Yeah, so around like 17.7. So 17.7 thousand month if you do, and if you get 7% for 30 years, then you will end up with 2 crores. Okay, provided you do it continuously for 30 years without any break. Okay. So that's one thing. Now, yeah, let's do some other problem. Okay. So this was between A and F, right? So you can do the reverse case also. So you can start with some A value that, let's say you do 10,000 of SIP per month, and you get interest rate of let's say 6% or something annually. Then how much would you end up with after let's say 20 years? Okay, so I'm just giving it the reverse case because you know I can ask the same problem in reverse case, where I will mention that I'm doing SIP of, let's say, 10,000 per month. Okay, interest rate I get is, let's say, around 6% per annum. Okay, and let's say after 20 years, how much is the future value or final lump sum amount that I end up with? Okay, so here you can do quickly, it will be like 1.2 lakhs per annum, because your interest rate is in annum, right? So convert everything in 1 unit. Okay, so then you can find this F, right? So it will be nothing but F will be A into 1 plus I power n minus 1 divided by I, or A into this factor of F by A comma I comma n. Okay, so I have this table, so I'm just doing it from there so that we'll not do the same thing again and again. So this is like 1.2 lakhs, right? So let's say 10 to the power 5, and this F by A for I equal to 6 and n equal to 20 is let me just see. Okay, we want F by A. Okay, so F by A is nothing but 33.786 36 point, sorry, 36.786. Okay, so that means you have 38.786 into 1.2 into 10 to the power 5. Okay, so we will have around see, basically it will become 37 times, right? So 46.54 lakhs. Okay, I mean exact number you can calculate, but this should be your final amount that you get after 20 years. Okay, so because you invested, let's say, 1.2 for 20 years, so total you have invested 24 lakhs, right? Yeah, so 10 years it is 12 lakhs, so 20 years 24 lakhs, and because of the interest you get 46 lakhs as total. So almost you got 22 lakhs as the interest on your investments. So you should repeat this calculation with, instead of 6%, if you repeat it with the 10% interest rate, you will see a huge difference. Okay, I'll just give you the factor. See here, this factor is around 36, right, or 37 if you get the 6% of interest rate. Let's say by some miracle you achieve some 10% interest rate for 20 years. You did some investments in your portfolio or somewhere. So then what you'll get is around 57. Okay, so instead of 37 times, so basically whatever annual investment you do, that will, instead of becoming 37 times, it will become 57 times. Okay, so basically that will be 57 into 1.2, and you'll end up with how much? 57 into 1.2, right? So roughly 68 lakhs. Okay, so instead of 46 lakhs, you'll end up with 68 lakhs. So that is the power of this I. This I, it's a very innocent looking term here, but in real life, that is what majorly determines your final outcomes of your investments. And that is the reason people usually go to the equity markets, because if you just rely on your fixed deposits, etc., you'll get a lower rate of interest. And if you do equity markets or any other uh, form of investments, you may get higher interest rates, and finally you'll end up with significantly higher value after a sufficient longer time. Okay, but the problem is in equities, etc., the interest rate is not constant like your FD interest rates or debt mutual funds or debt instruments. inequity, it is fluctuating, but it has been seen that it will be more or less GDP plus inflation plus some growth premium that you get for your economy. So I think for Indian market, it's around, so far it was around 15% or 12 to 14% roughly, but now the growth is not there. So let's see what happens. Or growth is moderating down. It is not as high as it was. Okay, so anyway, let's leave that. Let's take another problem. So this was FA, right? So now we can do AP also, because the two cases that we have in your EPS series, this F and A are related, but then there are cases where A and P are related. Okay, so you can do that also. So let me just see if we can have some problem for that. P and A, right? So yeah. Okay. So let's take this question. So a loan of, let's say 4 lakhs, 4 lakhs is to be repaid in 6 equal payments, 6 equal annual payments, let's say. Okay. At 12% interest rate, compounded annually, the value of an installment will be. Okay, so this is the application of the other two types of EPS formula. Okay. So here basically what they have given you is they have given you P value, which is 4 lakhs, because this is the amount of loan that you have taken today, not in the future somewhere. Okay. So then you need to repay this loan in 6 years, because it's an annual installment, and they're charging interest rate of 12%, so 0.12. Okay. And now you need to find what is the A value. Okay, so if you go back to the formulas, they're asking about this case number. One second. Yeah. So they are asking about this A equal to P formula, right? Yeah. So this one. So you need to use this formula for solving this problem. Okay. So it is nothing but F into I by this one, right? So F you can write it as see, A will be P into 1 plus I power n. This is nothing but F into I by 1 plus 1 plus I power n minus 1. Okay, so this is the formula you should use if you don't have any tables with you, or otherwise it should be A by P here for certain I, certain n. Okay. So this thing, this P into I plus n. So I mean I have the table also, but I'll just do it for your convenience or for the sake of completion. So this will be 1.12 power 6. This will be 0.12 divided by 1.12 power n is 6 here, minus 1. So let's see if we get the same answer as the factor. So you have 4 into 10 to the power 5 into 1.2 1.12 raised to power 6 into 0.12, and basically you divide this by 1.12 power 6 minus 1. Okay. So yeah, you are getting approximately or exactly 97290.3, and if I use the factor, then it will be nothing but, I mean, these are not equal because these are two different methods altogether. This will be 4 into 10 to the power 5 into, this factor is for A by P 12%, 6 years. Okay. So 12% A by P 6 years. Okay, 12% A by P 6 years. So it is 0.2432. So I think you should get the same answer this way also. Let's confirm. So it will be 4 into 0.2432. Yeah, 97280. So I mean, there is a slight difference in the final answer because um, you know this is exact value, right? And this is only rounded off up to 4 digits. So in this case, like in the exam, if they have given you the table, you have to calculate with whatever data you have. Otherwise, you have to give this as the correct answer. Okay, so those things are there. Okay, so this is now the case where you are doing from A to P. There will be a reverse case where you are doing from P to A, right? So let's take that case also. Then basically we are going one by one, and this thing, we will then go to one problem on deferred annuity. Okay, so um, yeah, so this is the reverse case now. So let's take this problem. Uh, you know, so cash flow of 30K, 30,000 is generated at the end of each year for 6 years at 12% for maintenance of the equipment. See, basically what they are saying is there is a machine which is generating 30,000 cash flow per year, but it is, the maintenance rate. So here it's not interest rate, but it's like the rate at which the maintenance cost is compounded annually is 12%. So the amount that can be invested now to cover the maintenance cost for the equipment will be. Okay, so you need to basically find how much you need to invest now. Okay, so oh, actually, sorry, this cash is not generated by the machine. I mean, you need this much cash equally. Okay, so here it's like that. So basically what they are meaning is you have this equal this thing equal annuity or maintenance cost for each year, and this I value is 12% here, so basically 0.12, and n is 6 because it is to be done for 6 years, and they're asking what is the current value that you need to invest, and so that you can cover the maintenance cost, which is at 12% per annum compounding. So it's the reverse case of the previous problem. So here P will be nothing but A into 1 plus I power minus n, and then it will be 1 plus I power n minus 1 by I. Okay, so if I'm not wrong, yeah, see, basically this is the you just take this factor on the right side and then you get this relation, or otherwise it could be A into P by A comma n. So I'm not doing this calculation because it's straightforward and it will take some time. You can do it on your own. Okay. So I'll just use the table here because we have done this calculation a lot of time by now. So it should be, the only thing is you should not commit any calculation mistake like what I did some time back. Okay. So it would be great if you get these tables in your exam, but I don't think so. So you should be thorough with your, I'm not sure, it can happen or it may not happen. So that's why you should be thorough with your problems also, formulas. Okay. So now here we want 12% n equal to 6. 12% n equal to 6, and we want the P by A. Okay, so P by A will be 4.111. Okay, so 4.111. So that will be 12.333 into 10 to the power 4. Okay, so basically it will be 123,330. Okay, so you need to invest this much amount today, which is, if I'm not wrong, yeah, 3330, right? So 1,23,330. Okay, so let me just check if that's correct. Yeah, I mean, if you do exactly using the formula, you'll get 342 at the end. But here, one second. Yeah, 41114 is there. Yeah, 1,23,000. Yeah, correct. So exact answer will be 1,23,342. Here we are getting 330 because of this rounding off up to 3 digits. Okay, so if you have even more refined table, it's nothing but 4.114. This factor, it's 4.114. But since we don't have table, I don't have table with that accuracy, there is a slight difference in the exact answer. Okay. So now let's take one problem from this uniform and this geometric progression series, etc. So uniform GPS, let's take. Okay. So let me see. Okay. So I think a similar problem is there in your this thing also. What you say? Your assignment also. So let me just see. Okay. Okay, so see, when you solve this uniform GPS series formula, you should remember one thing. Okay, so we'll take two problems. Let's see if we have time or not. Okay, because if you understand this, I mean, geometric series, etc., you can do on your own. Because the thing is, um, see, in these problems, I mean, we'll do one geometric series also, simple problem. But here you should understand how to calculate this A, which is your amount, and then they will ask you what is the final amount that you get. Uh, uh, what you say after, let's say, you do some investment, what is the final future value that you get? Because you know you do these installments, they will have some interest on them, and then at the end of n years you should have some final amount, right? So that is the whole question that can be asked from this. Okay, so uh, you know uh, okay, so one question that they ask is, this gradually or uniformly increasing or decreasing annual payments are there, right? So they will ask you how to find equal annual payment. Okay, so let's take that problem. Okay, so you need to find the value of equal annual payment series for paying a series of 6 years beginning with, let's say, 50K, 50,000 rupees, and decreasing at the rate of 6,000, sorry, 6,000 or 6K per year. Okay, at 12% rate compounded annually. Okay, so this is one variety of problem that they can ask. So here what they're asking is, see, your annual these things, annual payments, let's say A1 is around 5K. Okay, so then you'll have A2, which will be around 5 point, it is decreasing, right? So it will be shorter. Okay, so let's say you have A1 like this, and let's say A2 is something like this. Okay, so they are asking, it will be, 50, right? So A1 will be 50K, then you subtract 6K from it, so this will be 44K, like that, no? And it's basically going down, so with the uniform slope. So it will be something like this, something like this. So now what they are asking is, if you want to convert this in a equivalent amount, uh, but that amounts need to be constant. Okay, so like this. Okay, so what will be this value? So that is the whole question here. Okay, oh sorry. Okay, so now this will be certain, a equivalent, let's say. So now the question is, what is this a equivalent which will be similar to this uniformly decreasing series? Okay, so here you need to use this formula, which is nothing but, um, where is it? Yeah, here. So basically you need to take the help of this gradient formula, and how do you do that is, basically you take, yeah, so basically this a equivalent, which will be nothing but the constant amount for 6 years, will be nothing but your initial investment in your uniform series minus the gradient, and then you need to use this A by G for given interest rate 12% for 6 years. Okay. Now this A by G, where is it? Do we have it here? Yeah. So this A by G comma IN is this formula. So you can directly also do this, but I don't have time for that now. So I'm just using the factor given in the table. Okay. So if you do this way, what you get is A by G 12,6, right? So this factor is see, A1 is 50k, so that is there. G is 6, and this factor is 2.172. So you need to look into the table for 12 and 6. Okay, so 12% rate 6 years. Yeah, so A by G is 2.172. So if you do the calculation, this will come out to be around 36968. Okay, so if you do equal payments of this much amount for 6 years, then that will be exactly equal to the this uniform series of 50k decreasing 6k per annum. Okay, so this is one type of question that they ask from uniform series. Another question that they ask from uniform series is they will ask this A equivalent. Okay, so first find A equivalent, and then they will ask you to find the F. Okay, so we can take one question like that. So since we don't have time, I am just reading the question to you, or maybe I'll write it. Okay, so this is you can get some question like this. Okay, so a person plans to save 4,000, 5,000, so on and so forth. 1,000 rupees increase per annum. Okay, for 15 years. Okay, and this is annual increase. Okay, so and if his investment earns 12% compound interest per annum, then the amount, or then basically the final amount after 15 years is what? Okay, so this is the question. So this is like first you need to find A equivalent, because this is a geometrically uniform increasing series. So here your A equivalent will be, or before that, here your A value or A1 is 4,000, G is positive here 1,000. Actually this formula is like this, okay, but since here it was decreasing, so plus minus 6. Okay, so now it will be plus here. Okay, and then you have I of 12%, n is 15 here, and they are asking what is the f after n. So in this type of questions you need to find first the uniform installment, so that you can use the f formula for that. So that is nothing but a1 minus or a1 plus g A by G I comma n. Okay, so this direct formula or exact formula is also in your notes, but we'll use this one because we don't have time now. So this will be 1,000 positive. Okay, then this A by G comma I comma this thing, is, if you go back to your tables or if you calculate from your formulas, it should come out 4.9803. Okay, and then this will be nothing but 4,000 plus 4,980, so 8980.3. This will be your A equivalent amount. And why do we do this is because we now know the formula for equal EPS formulas we wrote, right? So this EPS formula where you have F and A known. Okay, so yeah, the first one. So there you have to put AQ instead of A. So you'll have AQ and then this formula I plus 1 power n minus 1 by I, or you can just write it as AQ F by A for given I and n. Okay, so you can do it both the ways. So I'll do it using the table. So F by A for I equal to 12 and n equal to 15 is nothing but 3, 7. I think we did this, but let's write it here. So it is 37 times. I think we previously got this in some problem also previously. Okay, so therefore the F that you get is nothing but 3, 3, 4, 7, 8, 3. Okay, you can verify this. Okay, so you should, again I can ask you one more question in this, that what is the total interest that the person got after 15 years. So what you need to do is you need to find the total investment. So this will be arithmetic series going from 4k to some amount after 15 years, right? So you need to first find the 15th series of the series, 15th term of the series. Then you need to find the sum of the series by using the formulas that we discussed in previous classes. Then you subtract that total sum from this F value to get the interest. Okay. So I'm not doing that part because you can do that, and you can expect this type of questions for examples. Okay. So this is for your uniform series. Okay. Now this geometric series, see, the thing is, this formula is difficult to remember for geometric series, right? This one. So uh, you know but you don't have any option. You have to remember this, or otherwise you have to use this. One second, somebody's mic is on.
इसको जो है ना मैं अपडेट का ये सीरीज होता है ना, ये डीप सीक क्या है, अरे AI है, ठीक है, ये करते हैं ना, ये देखिए आस्क इन पर्सन है ना, ये करना पड़ता है, अप्रूवल करना पड़ेगा.
Okay, one second, somebody was saying something in the chat. Let me just check. I joined now. Where can I get the recording? It will be there in your NPTEL coursework only. I mean, the page where you get weekly videos. There is one download videos option, or some session. One more option is there. Let me just tell you. Yeah, problem solving session. One option is there. You can click on that. Then you will get one OneDrive link, and then you will have there all the formulas. Okay, I mean video and these notes also. Okay, so basically you need to use this formula for this geometric series question. Okay, I'll just copy this so that I can use it later on. Okay, so let's take one geometric series problem. Okay, maybe I'll paste it here. Oh, yeah, what happened? It did not get copied. Leave it. So it is showing blank. One second. Where is it then? No, it is there. No, there is one option. I can't do this, man. I can't provide you links in the chat box. The link is there. You have to click here, then the link will open. Okay, it's there. I just checked, so you should check properly. Okay, anyway, we don't have time now. Let me just take this problem on geometric series. But yeah, it's there. You have to click here. There is a hyperlink there. Okay. Okay, wait till the class end. I'll show you because right now I'm doing something. Okay, we'll do it later. Okay, so this thing is a geometric series problem. Okay, so they have given that with first year end payment of 20K and further every year payment decreasing at 8% per annum. Okay, up to end of year 2, end of year 12. Okay, at the interest rate of 15%. Will be how much? Okay, so this is the question. So here, this is basically a geometric series question because they have given you G also here. So basically you have A1 of 25K. G is minus 8% here. Okay, so it is minus 0.08. Okay, I is 15, so it is 0.15, and N is 12 because they're asking at the end of 12 year what is the case. And what you need to find is you need to find the this thing, how much you need to invest today. Okay, so basically you need to find P here. Okay, so in this question it is not clear. So basically find P. Find P here. Okay, so now we have to use that formula, which is nothing but P equal to A1 by 1 plus G. Then you have some complicated stuff, right? Let me just copy paste it if I can again. Okay. Okay, so this is the formula. Okay, and otherwise you can write it as A1 by 1 plus G. In the bracket we should have this G dash and N, and here it would be I think P by A if I'm not wrong. Okay, so let's first find G dash. What is G dash here? 1 minus 0.08 divided by 1 plus 0.15. Okay, so 0.92 by 1.15, so it's greater than 1. That is the first thing. Okay, if I'm not wrong, let me just check. G dash, 1 second. G dash is the formula for P. Oh, there is minus 1 is there. Oh, okay, sorry, I forgot this one. There is one error in this formula. There is minus 1 here. Okay, so if I put that, okay, so yeah, so here 1 minus 1 is there. So 1 plus G 1 second, it is 1 plus I. Yeah. Okay, sorry for this mistake, but it is 1 plus I by 1 plus G. Yeah, now it is correct. Okay, so this value will be nothing but 1 plus 0.15 minus 0.08 minus 1, 1.15 divided by 0.92 minus 1, and it comes out to be 0.25. Okay, I'm skipping a step here, but you can verify that. And then you can put this G dash value in your formula here, or otherwise you can use this one. I'll use the table one. You can cross check this by doing exact calculations. So this will be 25 divided by 1 plus G, that will be 0.92 because G is negative here. Then for G dash of 25% and n equal to 12, right? So let me check. N equal to 12 and G dash of 25%. Okay, so 25% and equal to 12. We want P by A. Okay, so P by A is 3.725 as per this table. And let's just see if it makes if it is correct. Okay, so 25,000 into 3.725 divided by 0.92. Okay, so 101,222. So by this, yeah, it is correct. Okay, so this is your P here. It is 101,222.3. Okay, by this formula, exactly it will be slightly different in rupees. Okay, so this is how this geometric series calculations should be done. Okay, so I think in geometric series you can expect this type of problems. In some cases they will give you G dash, which is slightly in this case G dash was greater than 1, less than 1, it was 20.25. In some cases they will give you G dash greater than 1, and then you need to use the formula. Okay, so this is the geometric series problem. And now, since we are at the end of the class, let's take one problem on deferred annuity. Okay, so this means you don't start your payments or installments from year 1. You start your things after certain number of years. Okay, so common example is of education loan. So you take the loan and you start paying the interest after certain number of years, right? You don't immediately start to pay off the debt. Okay, and then those things are like that. Okay, so let's take one problem of this deferred annuity, then we'll stop for the day. Okay, so this is the problem of deferred annuity. Oh, there are two N's in annuity spelling. This is the problem. Okay, so the question is a person, same question I can frame in terms of student loan terminologies also, but I'm giving it like this. So a person plans to retire in 10 years. And wants to receive 50K per year. Okay, so this is like he wants this pension of 50,000 per year for 15 years after his retirement. Okay, if the interest rate is 8% per annum or per year, how much should he invest today, okay, to achieve this goal? Okay, so basically this is the question on deferred annuities. And what I mean by deferred annuities, I have already explained that you don't start getting the payments or installments from year one. You start it on a later date. Okay. So here, um, you know, in this type of problems, you should see basically what is happening here is, let's say this is your current day, right? So he wants after 10 years when he will retire, for next 15 years he wants some amounts, right? Like this, equal amounts he wants. Okay. So today, how much he should invest? That is the question. Okay. So, in this type of questions, you need to take some different approach. You can, direct going by formula doesn't help. Okay. So, start from here. Okay. So let's say we are after 10 years, we are on the verge where he is about to retire. Then, for next 15 years, he wants certain investment, right? So that he will have annual payments of 50K annual payments for next 15 years. Okay. So if you start from here at this juncture, the present value after 10 years is P10 will be nothing but A into 1 plus 1 plus I. Oh, sorry, it is minus 1 plus. Uh, 1 second. Is it like this? Let me just check. It is basically P and A correlation between EPS formula. Yeah, P and A. Actually, it is F only, but 1 second. Let me just check. One minus I. Okay, so where do we get that? P and A, right? So it is somewhere here. One second. People are calling me. I don't know why. 3 calls came just now, so that's why I'm distracted. 1 second. What is happening here? We want P in terms of A, right? So yeah, this array. 1 second. Sorry, guys. See this formula we have to use. Okay. So you can simplify this formula, right? You can divide both sides by 1 plus I power n. So in that case, it simplifies like this. It is nothing but 1 minus 1 plus I whole power minus n by I. Okay, you can do the simplification on your own, but this is what you get. Okay, so we are just using that. So here, yeah, it is 1 minus I by I. 1 second, guys. I think there is some emergency. I'll just come. Yeah, sorry guys, there was some emergency. Okay, so here basically when you are at uh, 10 number of, like after 10 years you're standing at this point, then for next 15 years you want this payment of 50,000, right? So therefore this P10 is nothing but 50 into 10 to the power 3. 1 plus I is 8, right? So it is 1.08 power minus 15 by I, so 0.08. Okay, so this is value at after 10 years. Okay, so we are starting from here because it is easier to solve problem in this fashion, but this is not the value at current point. Okay, so uh, if you calculate this, you should get around 4,27,974. Okay, so this much amount you need to invest after 10 years to get this much pension or annual installment of 50,000 till 15 next 15 years. Okay, but now this much amount, what will be its value today, right? So you need to uh, we need to uh, we need to discount this P10 back to today. Okay, and how do you do that? you know Basically you assume that this is the amount that you get. Let's say now you come to this n equal to 0 point, and now if you invest some amount today, after 10 years you want this much amount, okay, at 8% interest. So therefore P0 is nothing but this P10 by 1 plus I power 10 here, not 15, because now you are discounting it back to 10 years. Okay, so therefore it is 427,974 divided by 1.08 power 10. Okay, and therefore the amount that you need to invest today is equal to 1,98,235 rupees. Okay, so now you should understand how to solve these deferred annuity problems. So basically I can frame this problem in another way also, that if I invest around 2 lakh rupees today, how much will it become after 10 years if I get the interest rate of 8%? So that will be around 4 lakh 3,000, 30,000. Okay, and then if I use that amount to start my pension for next 15 years of equal payment at same interest, how much will I get? So in that case I should get answer about 50,000. Okay, so this is how deferred annuity problems should be solved. Okay, so you can try similar problem by considering some loan amount that you take today. How much will it be worth after 5 years? And then for next 5 to 10 years, when you're paying it back, how much installment, equal installment will you get? Okay, so similar problem can be fixed or framed there. Okay, so with that, we'll stop for the day, and I'll share these notes, etc. But I think one of the student was asking that he wants to see how do you access those things, right? So let me just check what he wanted to ask. Yeah, you can ask any doubts, Aman. It's not like this is one-way street. Oh, so you want uh, this thing, huh? So see, you just have to go to Google, and actually I joined this course as a student also. So see, you have to log in here, right? So once you log in, you get page like this. So you have to go to uh, problem solving session Jan 2025. Then you go to the recording. Okay. Acha, I got logged out. Okay, anyway, I'll log in again. Okay, so let me just log in. Okay, so then you have to go to problem solving session. There is a recording tab there, and then if you click here, it will open some Google Sheet, and then there are some links here. Okay, so I think it will take some time for this to open in my tab, because this I don't use tab for accessing that, but this is the way to do this. Okay, so I hope it is clear to you. You basically need to go into this this thing, problem solving session tab, and then on recording you'll get YouTube videos also and this class notes also. Okay, so with that, let me just share the notes. Okay, I'll stop presenting now. Okay, so the class is over. I mean, you can leave if you want. Okay, so I'll just share the notes and video on the link that I shared with you just now. And next class will be on Tuesday, same time. Okay, so see you next time. Okay, bye. Good night. One second. Yeah, stop presenting. I mean, whatever we are discussing, this type of questions you can expect in the final exam also. Exactly which type of question will come, I also can't tell. No? Let me just see. I uploaded it somewhere. It doesn't come. Okay. Okay. So, yeah, see you next time. Bye.